Students, good morning. Today I am going to solve a simple problem. The problem is calculate the rate of diffusion of acetic acid. This is component A, acetic acid, across a film of non-diffusing water. Component B is water. Diffusion of A through non-diffusing in liquids. Steady state molecular diffusion in liquids. The problem comes under the category of diffusion of A through non-diffusing B. Component A is acetic acid, component B is water. The film thickness is 1 mm. Steady state molecular diffusion in liquids. Diffusion of A in non-diffusing B. Clear? Right. Film thickness is given. First one. Acetic acid is component A. Acetic acid is component A whose molecular weight is 60.03 kg per kg mole. Next, component B, water. Component B is water whose molecular weight 18.02 kg per kg mole or gram per gram mole, whatever it may be. Film thickness is given. That means 1 mm. Z is given. Z is equal to 1 mm. It is equal to 1 into 10 to the power of minus 3 meter. Thick. The concentration on both sides of the film are respectively 9% and 3% by weight. 9% and 3% by weight. See, this is the location 1. This is location 2. The film thickness is 1 into 10 to the power of minus 3 meter. Film thickness is given. In section 1, A is 9% and B is 91%. In section 2, A is 3%, 9% and 3%. A is 3% and B is 93%. So for example, A and B both are 100 grams. Base is 100 grams. Means A is 9 gram, B is 91 gram. In section 2, base is 100 grams. Then A is 3 grams, B is 93 grams. So weight is known, molecular weight is known, weight divided by molecular weight is mole. In section 1, moles of A. In section 1, moles of A, 9 divided by, what is this? 60.03. In B, component B, 91 divided by 18.02. This is weight, this is molecular weight. Weight divided by molecular weight is equal to mole. Weight divided by molecular weight is equal to mole. So 0.1499 moles of A. Similarly, 5.0499 moles of B in region 1. Next, 3 grams of A, 93 grams of B. So moles of A is equal to weight divided by molecular weight, 3 divided by 60.03. That means 0.4998 moles. Moles of B, 93 divided by 18.02. That means 5.3829 moles of B. So moles of A, moles of B, total moles is equal to 5.1998. This is the total moles in section 1 or region 1. Similarly, total moles in region 2, 5.4329. 5.4329 moles. Next, mole fraction of A and B in region 1, mole fraction of A and B in region 2. So mole fraction of A in location 1. Mole fraction is nothing but individual weight divided by total weight. Individual moles divided by total moles. So individual moles 0.1499. Total moles 5.1998. So mole fraction of A in section 1 0.0288. Mole fraction of B in section 1 individual mole divided by total mole. Individual mole 5.049 divided by 5.1998. Mole fraction of B in section 1 0.9712. Similarly, mole fraction of A and mole fraction of B in region 2. Individual mole divided by total mole. Mole fraction of A in region 2 is equal to individual mole 0.4998 divided by total mole 5.4329. The answer is 0.0092. Similarly, mole fraction of B in section 2. Individual mole 5.3829 divided by total mole 5.4329. The answer is 0.998. Now we determined the mole fraction of A in region 1, mole fraction of B in region 1. Similarly, mole fraction of A in region 2, mole fraction of B in region 2. Okay, what next? Average molecular weight in region 1. Average molecular weight in region 1. Average molecular weight is nothing but mole fraction into component A plus mole fraction into component B. Mole fraction into molecular weight of A plus mole fraction into molecular weight of component B. This is A, this is B. So mole fraction of component A in region 1 0.0288 into its molecular weight 60.03 plus mole fraction of B in region 1 0.9712 into its molecular weight 18.02. Molecular weight, average molecular weight of component A and B in region 1 is equal to 19.2299. Weight unit kg per kg mole or gram per gram mole. Average molecular weight. Next, density divided by molecular weight. For 9% solution, the density is 1012 kg per meter cube. For 9% solution, the density is 1012 kg per meter cube. So 1012 divided by 19.229. So the answer is 52.6244 K moles per meter cube. K moles per unit is K moles per meter cube. Similarly, in region 2, average molecular weight. Again, molecular weight, mole fraction into molecular weight of A, mole fraction into molecular weight B. The same should be adapted in region 2. Average molecular weight. M average is equal to 0.0092 into molecular weight of acetic acid 60.03 plus 0.9908 into molecular weight of water. So it's equal to average molecular weight in section 2 18.4065 kg per kg mole or gram per gram mole. Clear? Again, density divided by molecular weight is equal to, for 3% solutions, density is equal to 1003. 1003 divided by 18.4065. The answer is 54.5025. 54.5025 K mole per meter cube. This is region 1, this is region 2. Here it is 9% A, this is 3% A. Clear? So now we arrived in region 1, rho by m is equal to 52.6244 and rho by m is 54.5025 for region 2. This is region 1, this is 3 into I am in need of rho by m average. Rho by m average. That means 52.6244 plus 54.5025 divided by 2. The answer is 53.5644 kmol per meter cube. Now we established. What next? XB mean. XB mean value. That means XB2 minus XB1 divided by ln of XB2 divided by XB1. Clear? Right. What about the XB2? XA1 plus XA2. That means mole fraction of A in 1, mole fraction of B in 1. Similarly, XA2, XB2 all are variable. I am going to substitute directly in this equation. XB mean is equal to XB2 0.9908 minus XB1 0.9712 whole divided by ln 0.9908 divided by 0.9712. So the answer is XB mean value is equal to 0.9810. The equation to estimate the rate of diffusion or flux in case of diffusion of A through non-diffusing B, that is NA is equal to DAB divided by Z into rho by M average into XA1 minus XA2 into XB mean value. So what next? DAB is given, diffusivity of acetic acid in liquid 0.95 into 10 to the power of minus 9. 0.95 into 10 to the power of minus 9 divided by film thickness 1 into 10 to the power of minus 3 into XB mean value 0.9810. Then rho divided by m average value. Rho divided by m average value 53.5644 into XA1 minus XA2. XA1 0.0288 minus XA2 0.0092. So the answer is, the final answer is 1.018 into 10 to the power of minus 6 kmol per meter square into second. This is the answer. 1.018 into 10 to the power of minus 6 kmol per meter square second. The problem is very simple, but it takes quite long time to estimate XA1 and XB1, XA2 and XB2. Without this, we are unable to calculate rho by m average. Clear? Thank you.